Hello class, this is Mr. McAllen again, and we're going to work on 27 and 28. And for the first one, what we're looking at is find the oblique asymptote for the rational function. So when you look at the equation for a rational function, the overall degree should be 1 if you're looking for an oblique asymptote. So here, if you notice, the degree of the top is equal to 2 and the degree of the bottom is equal to 1. Thereby, the overall degree of that rational function is 1. So as a result, if we do long division and we divide x squared plus 8x minus 7 by x minus 5, we'll get our oblique asymptote. And remember, an oblique asymptote will always have an equation of a line. So you're just looking to take the long division to the point where it looks like mx plus b. So what's the first value that you can multiply this by to get x squared? And that would be x. So then you multiply x by x minus 5 and you get x squared minus 5x. Now remember in a division problem that we're always subtracting that amount, that quantity. So I'm going to subtract both of those terms, and x squared minus x squared is 0. 8x minus 5x will be as if you're adding 8x to 5x. So it'll be the negative makes it positive, so you have 13x. And then we bring down the negative 7. And now we have our next term. So what do you multiply this quantity by again to match up with the 13x? And that would be positive 13. So then we multiply by 13 and we get 13x minus 65. And we really just want to make sure that when we subtract this term that we did in fact get rid of that x term. And now we end up having our equation of the oblique asymptote is what's on top here, and that would be x plus 13. So look at answer A is correct, but they're trying to trick you with answer D. So we would put answer A, and that would be what our oblique asymptote equation would be. So on the next problem, we want to simplify the difference quotient. So in simplifying the difference quotient, they give us what the difference quotient is. So here we have f of x plus h minus f of x all over h. So when they give you the equation f of x is equal to 9x squared minus 9x, they've already given you half of the difference quotient. So I'm just going to rewrite this difference quotient. We have f of x plus h minus the quantity of 9x squared minus 9x. That's all over h. And now we have to fill in the f of x plus h part. So we'll do that over here. F of x plus h. So all we're doing is we're plugging in wherever we saw an x before, we're plugging in x plus h. So that's going to look like, 9 times x plus h squared minus 9 times, this is going to be x plus h instead of just plain old x. So I'll write that into the difference quotient. So we'll have 9 times x plus h quantity squared minus 9 times x plus h minus the other part that was there before, 9x squared minus 9x all over h. So then we're going to work through this, and I have to FOIL this term out. That's first, outer, inner, last. Remember, it's not just 9x squared plus 9h squared. It's going to be 9. It's going to be x squared plus 2xh plus h squared minus, I have to just distribute the minus 9 x minus 9h, and then I have to distribute the negative in the last part of minus 9x squared plus 9x. That's all taken over h. And my last bit of work is to multiply the 9, distribute the 9 through the three terms here. So I have 9x squared plus 18xh plus 9h squared minus 9x minus 9h is 9x squared plus 9x all over h. Now everything should cancel out. If you did this correctly, you should notice that quite a few terms cancel out, and we should be able to get the h to cancel out of the denominator. So let's see what happens. So we have the 9x squareds cancel. We have the 9x's cancel. And we write up what's remaining. We have 18xh plus 9h squared minus 9h all over h. And we end up for our difference quotient. The h factors out of the three terms in the top. So we'll have h times 18x plus 9h minus 9 all over the h in the bottom. And now the final simplification is canceling out the h with the top, the numerator and the denominator. And our final simplified difference quotient is 18x plus 9h minus 9. That would be your simplified difference quotient. And let's hopefully we match up with one of the answers. Let me just zoom out so we can see the whole problem. 18x plus 9h plus 9, and that would be choice D. That says minus 9. Let's see. No, let me look and make sure I didn't make a mistake. I'm just going to pause and check my work and then report back to you. Okay, I'm back, people, and I've found what my mistake is I wrote the problem down wrong in the beginning. So you see here the problem was f of x, and this is why you should always show your work so it's easy to trace your mistakes. It should be a plus. So I'm going to just make this change here, and I'll do it in different color ink so I can track it. This should have been a plus. This should have been a plus. So then when I get to this work here, that should have been a plus, and this here should have been a plus. And then this thereby should have been a plus here and here. And this is still a minus, and this becomes minus. This should have been a plus, and then that would have made this a minus. And tracing all the work down, that would have been a minus. That would have been a plus. This would have been a plus. And then the resulting cancellations, they still work. So I have 9x squared minus 9x squared. 9x and 9x still cancel. And as a result, my final term here is plus. My final term here is plus, and my difference quotient would have been the answer matching D. So, you know, a lesson for everybody, make sure that you copy down the original problem correctly so you don't have to deal with what I just had to deal with. Hope this helps, and remember, this is for review, so whatever components of this you feel you need to incorporate on your note card, you should do so now. So hopefully you'll tune in for 29 through 32 on the next video.